So hello everyone, so today we have special contest, we have multiple problems about bracket sequences. So bracket sequence is an interesting topic, it's not something that you put in your algorithm course because it's not really about algorithms, it's not really about data structures, it's just interesting object to analyze. Yeah. So a lot of problems in competitive programming are about bracket sequences. Yeah, like you see today. It's very interesting actually to learn what do we know about bracket sequences and how do you work with bracket sequences. So let's see what we have today. So the results are pretty good actually. So not that many people solved the contest today, unfortunately. So if you see in this and you not participating, just solve the next contest. We have very nice contests every week. Good. So let's see what we have. We have bracket sequences. Bracket sequence defined different way in different problems. Like in this problem, they define bracket sequence by saying that you can add some pluses and ones into this bracket sequence to have a correct arithmetic expression. It's kind of strange definition because it uses definition of correct arithmetic expression, which is actually more complicated thing than, oh, sorry, what I pressed. Sometimes I press something, I don't know. This is actually the more complicated thing than a bracket sequence. So bracket sequence is just a sequence of brackets such that if you go from left to right, for every opening bracket you have some closing bracket. Yeah, like this. Also, let's draw something. So so you have some sequence, you have some opening brackets, you have some closing brackets. And these opening and closed brackets, they form some pairs. So this bracket is paired with this bracket is paired with this bracket. So what are the main properties of bracket sequences? Again, we have equal number of opening and closing brackets. That's important property, yeah. And they can be split in pairs in such a way that these segments, they never intersect. They may be even either non-intersect or they may be nested like this. So we can put one pair of bracket sequences inside another pair of bracket sequences, but we cannot do it like this or anything else. So we split all bracket sequences in pairs like this. We open, close, and here we open, close, and so on. Now, in all problems today, we have bracket sequence of only single type. So we have only bracket sequence, like normal bracket, normal brackets like this. How called circle brackets? Yeah, I don't know how to. No, normal brackets. So we have only one type of brackets. So in this case, we actually, even if you have two intersection brackets like this. So if you have open, close, and you have open, close, you can instead pair them like this. So actually this intersection doesn't matter. This intersection will matter if you have like multiple types of bracket sequences. So you have like this sequence here, and then you have like square brackets like this. Then you cannot match them like this, because you will match different types of brackets. It will not happen today. So today we only have one type of brackets. So actually a situation like this is not a problem. What is the problem? When the sequence is not regular. Sequence is not regular when we have some opening bracket which we cannot close. For example, if we have closing and then open, then we have like equal number of open and closing brackets, but we cannot match them. Yes, because we need to open and then close. So actually, the only thing we matter is that all the opening brackets go to the left from the closing brackets corresponding. Yeah. So for every opening bracket, we have corresponding closing bracket, and it goes to the right from this position. Good. No, first, let's remember what we know about bracket sequences. How do we check if we have a regular bracket sequence or not? Let's check. So, how do you check if you have correct bracket sequence? Let's do some bracket sequence like this. Basically, what we do, we go from left to right, and we maintain the current number of opening brackets which are not yet closed. So we go from left to right here, and just count how many brackets do we have. So we start by having 0 brackets, then we have one opening bracket. So now we have 1, then we have second, now we have 2. Yeah. Then we close bracket, so we to take one of the opening brackets and close it. Then close this bracket. Well, now we have 1. Then we have again close, we have 0. Then we have 1, we have 0. Yeah. So every time we see opening brackets, we increase counter by 1. Every time we see close bracket, we decrease counter by 1. Plus 1, minus 1. And what we need, we need this counter to be non-negative. So we look at this number and make sure it is always non-negative. So if this counter is always non-negative, it means we never try to close the bracket which we cannot open. Yeah. Another thing we care about is this last number. So the last number should be 0. So all numbers should be non-negative and last number should be 0. And then you have a correct bracket sequence or regular bracket sequence. Yeah. That's right. Another way to think about bracket sequences is in terms of like to visualize it. You can start like this. So every time you see open bracket sequence, you go up like this. Like here you go up, and then you go, and every time you see close, you go down. Then you go up, then you go down. So it's like open, open, closed, closed, open, closed. Yeah. And you have this line. So this line basically represents your bracket sequence. And you just look at this line and check that this line doesn't go below 0. Yeah? So if you look at this, so it's like they present your bracket sequence. If it starts at 0, it finishes at 0, and never go below 0, then you have correct bracket sequence. Now let's move to the problems. So the first problem asks you to check if the given pattern can be transformed to some correct bracket sequences. So you have some pattern which contains a lot of question marks and at only one opening bracket and one closing bracket. We need to change all the question marks with opening or closing brackets and check if it is possible to change it some way that you have a regular bracket sequences. Bracket sequence. Well, let's see. So how do we solve the problem? Well, first of all, let's think. So when it is impossible, you can look at the examples, or you can think about just of examples when you cannot make the regular bracket sequence. No, first of all, if you look at the second example, yeah, like this, you can see that if your length of the sequence is not even, so you have odd length of the sequence, then it's obviously impossible. Yeah, so if n is odd, then you have no. Yeah. Now, if the length is even, when it's impossible, again, you can look at the example. See another example when you have like this no. Again, why is no? No, because it starts with the closing brackets. If the first bracket is closing bracket, if the first bracket is closing bracket, and then anything else, then it can be transformed into a regular bracket sequence. And again, also no. Now, another case is symmetrical case. We didn't talk about this. So bracket sequence is kind of symmetrical structure. Yeah. If you look at this picture, you can read it from left to right, or you can read it from right to left. Doesn't matter. Or you can check bracket sequences from left to right or from right to left. You can do the same thing going from right to left. When you see closed bracket, you increase counter. When you see open bracket, you decrease counter. So it's very symmetrical thing. So when you have some case like this, you always can think about some symmetrical case. And yes, there is a symmetrical case. When last bracket is opening bracket, you also have no solution. Now, when we decide, we obviously don't have any solution, let's think, is there any other case? So if I have any other structure, so I have some sequence of size n is even. Yes, I have some opening brackets, some closing brackets, and it's not the first, not the last. So I have some opening brackets somewhere in the middle, some closing brackets somewhere in the middle. Easy. Oh, it's a boring example. Let's put some here, so it's more fun. Let's think. Is it possible to transform it into a regular bracket sequence? No. How do you transform it into regular bracket sequence? So I want to put some same number of opening and closing brackets. Yeah. And I want to again, if you look at this line again, so you want to get the line of the required length, and you want this line to be always above 0. And if you just look at normal bracket sequence, if you don't have these two pre-installed brackets, yeah. So the optimal way is always to go up and then go down. So you kind of keep your line as high as possible. Let's try to do the same thing here. So let's try to put all the opening brackets to the left and all the closing brackets to the right. So we put some opening brackets here. Let's see, 3 here, and we have some closing brackets here. So no, it's easy to see that this bracket sequence will be regular. No, because it always goes below, it goes above 0. It's never goes below 0. Yeah. So no, why? Because let's look. Every time I see the closing bracket, I have enough opening bracket to the left to close it. Yeah. Because let's look at this. So I have this closing bracket I add in the right part. For them, I always have enough. So when I started to add these brackets, I always added all these brackets to the left. And for this bracket, I always have at least one bracket to the left because it is not the first bracket. So this closing bracket is not the first one. So it's always at least one open bracket to the left. Then that's all. So again, if I put, you need to fill these question marks. Yeah, you can always fill them like this. You take the question marks, fill the first half with opening brackets, last half with closing brackets. And it's actually quite repetitive. So it happens a lot in the problems about bracket sequences. So when you think if it is possible to imagine you know how many brackets you need to add. So you have some prefix, for example, of bracket sequence and something you need to fill up. It's always optimal to fill the empty spots like this. So you put all the opening brackets to the left, all the closing brackets to the right. And if this bracket sequence is regular, then it's possible. If this regular sequence is not regular, then it's impossible. That's all. So that's how to solve the problem. You find the cases when you have answer is no, and just check that for all other cases the answer will be yes. You have 2 minutes to solve this problem. Oh yes, that's good. Here we check these 3 cases. Oh, that's good. Second problem. So in the second problem we have a definition of bracket sequence. But then we need to do something different. So what we need to do in this problem? We have some number of short bracket sequences of length 2. So if you have bracket sequence of length 2, you have 4 different bracket sequences of length 2. And we need to combine them in such a way that you have a normal bracket sequence. And just again, you output yes or no. In this case, you output 1 or 0 for some reason. I don't know why. So we need to check if it is possible to construct bracket sequence. Let's see. For example, in the first example, what do we have? What do we have in the first? Do we have explanation? Yes, do we have? We have explanation first example. It's not very informative, but yes. Let's check. So what we have? So we have some number of strings cnt1 of like this, then cnt2 of like this. It's 1, 2. Type 3 is like this, and type 4 is like this. There are 4 types. I know how many strings of every type I have. So in the first case, I have 3 strings like this, 1 string like this, 4 strings like this, and 3 strings like this. And I need to check if it's possible to combine them in such a way that I have a correct bracket sequence. Well, let's see. First of all, again, we need to check that number of opening and bracket sequences, or opening and closing brackets is the same. Well, let's see. So here, I have 2 opening brackets and no closing brackets. So I have like balance is 2. Yeah, for every sequence like this, the balance is 2. For every sequence like this, balance is 0. I have open and closing brackets. And here I have also balance 0, and here balance is -2. Yeah. So the situation is actually really simple. In these 2 strings, I have the same number of opening or closing brackets. And here I have 2 opening brackets, here I have 2 closing brackets. So in order to have the same number of opening and closing brackets in the whole sequence, I need these 2 numbers be the same. Yeah. So I need to check this cnt1 equals to cnt4. So that's the first thing I need to check. If it's not equal, then number of opening closing brackets is not the same. The answer is no. Now, if it is the same, is it enough to build the rest? No. Yes, we don't have this example. Good. So is this enough? No, you think about this. So let's check if it is enough to build the correct bracket sequences. It looks like it is enough because, well, let's look at sequences. Well, let's build sequences like this. So first, let's put all sequences of type 2. All sequences of type 2, let's put them here. They actually don't change anything. They don't change the total balance, and they don't. Now, I need to put somewhere the sequence of type 3. Yeah. So put this. I will put all opening brackets before. So I will put all sequence of type 3. Now I can put all sequences of type 4. Yeah. And then finally of type 3, type 1. Sorry. Type 1, here I put type 3, and finally put all sequence of type 4, like this. So it looks like correct bracket sequence. Yes, I have the balance here. The balance is always like 0, 1, 0, 1, and so on. Here it is 0. Here I just increase the balance to some numbers. So 1, 2, 3, 4. Here increase will decrease, increasing. It will be 3, 4, 3, 4. And so on, and here it will be decreasing. Yeah, so 3. I have 3 of them again, like this. So it looks like correct bracket sequence. The only problem is when I cannot build it like this. I cannot build like this, then I don't have anything here. So if these two parts are empty, then I cannot just insert this part here. So if CNT3 is greater than 0 and CNT1 and also CNT3 and CNT4, they are the same, equal to 0, then I cannot put this part anywhere. Yeah, because I don't have any opening brackets, any closing brackets, so I can't put this element anywhere. No, that's wrong. Again, you check all the cases when it's impossible, and after that, check that all the remaining cases are possible. No, they are possible because I can build it like this. So again, we have two problems when you actually don't need to know any algorithm. You just need to understand what's going on and check all the cases just by hand and find them and think about if it is possible to do it in all other cases. No, yes. Again, this is the whole solution. Oh, we built the array. Oh, why not? Yeah, no, why not? So instead of having 4 variables, you can make array of size 4. It's actually a nice thing to do. Yeah. Problem C. Again, we have definition of the bracket sequence. Now we have definition of subsequence. So subsequences also occur in different competitive programming problems. Subsequence is just when you take the sequence and remove some elements. So we have some sequence, and you remove some elements from this sequence, and look at the remaining elements. Just this, and take them in this order. So this is called the subsequence. And what we need to check in this problem, we need to find the longest subsequence, which is regular bracket sequences. No, of length exactly k. Sorry, I'm so sorry. Is it another problem? I believe we had problem. We have longest. No, okay. So in this problem we have initial is regular. Yes. You're given a regular bracket sequence. You need to find a regular bracket subsequence of length k. Okay. It's not a problem. Good. So how can we do it? There are multiple ways to do it again. So what we can do, for example, you can look at your bracket sequence. Let's build some long bracket sequence. Something like this. So I have bracket sequence. Again, all the brackets are split into pairs. So this pair did this, pair did this. Now, you can find these pairings just by going from left to right and maintain the stack of all the opening sequence. So how do we calculate all these pairs? We go from left to right and maintain the stack of the open bracket which are not closed yet. So go from left to right, take this bracket, it's not open but not closed yet. Then take this bracket, then we see closing bracket, we pair it with the last open bracket and remove it from the stack. Then we take the extra bracket and so on. So every time you see the closing bracket, you pair it with the open bracket, which was the last but not closed yet. Yeah, it's just the top bracket in the stack. So you can do it like this. Yeah, okay. Again, if you never did this before, it's fine, but it's not actually something that difficult. So let's integrate them. So I just go from left to right, and if you see the open bracket, you put it in the stack. So I have this stack. Yeah. So this is stack. So you see you see the open bracket, you put it in the stack. So you have the index of this open bracket is 0. Then you see another open bracket, you put it in the stack with index 1. Then you see the closed brackets, you take the topmost bracket from your stack. Now it's index. Now you can pair your two with one. So you pair these two brackets and remove it from the stack, and so on. So every time you see the open bracket, you put it in the stack. Every time you see the closing bracket, you pair it with the topmost bracket from the stack and remove it from the stack. It's actually really easy code. So if you never wrote it before, you just try it. It's not that hard. And again, so I remove this from stack, I remove this from stack. So again, you have closing bracket, take the topmost here, pair it with this 0, remove it from the stack. Now, after you build these pairings, so you pair all the open brackets with corresponding to closing brackets, you can just solve this problem. So what we need to do is this problem, you need to build any subsequence which is a regular bracket sequence. Now, what you can do, you can just remove any pair of brackets. So you can take any open brackets, take corresponding pairing closing bracket and remove them both from your string. And you will have a correct bracket sequence again. That's all. I believe this maybe this is even easier solution for this problem, but that's actually so. So after you understand how these bracket sequences are formed, so they form of pairs of open closing bracket sequence, or open or closed brackets. So after you understand that bracket sequence always form of these pairs, you can just find these pairings and then just do what you need in this problem. Just in this problem, you need to remove some pairs of brackets in such a way that the resulting bracket sequence is correct. That's all. So again, I will build this pairing and then just remove any pairs until the length is k. In the end, you can do it multiple. You can just mark them as removed. So if I need to remove one pair, I'll just remove this pair, let's say, and remove this pair. You can mark them as removed and then just go from left to right and print everything which is not removed. So this is all. I believe this is the easiest way. That's all. You can actually do it in the same time when you do this stack. So when you find these pairings, you can at the same time remove them. So if you find the pair, see if the length is more than k, just remove this pair just immediately. Not in the end, but when you need to remove. But again, there are multiple ways to do it. Another way to solve this problem is actually like I told you before. So when you build bracket sequence, it's like always optimal to put all the opening brackets to the left and all the closing brackets to the right. And when you remove brackets, you can do it again in reverse way. You can take all the closing brackets. You know how many you need to remove, so just remove it from right to left. So just not from left to right, from left to right. Just remove some brackets from the left, and when you have open brackets, just remove some of them from the right. Then you kind of keep all the open brackets to the left and keep all the closing brackets to the right. Yeah. Then if initial sequence was regular, then this sequence will also be regular. But again, this approach actually requires some intellect, but this first approach doesn't require any intellectual like operations. You basically take the background sequence, split it into pairs, remove some pairs, print the result. Okay, all the steps are very simple. So if you can solve the problem using some simple standard steps, just usually you do it like this. It may require a little bit more code than if maybe some intellectual approach. Maybe there is some easy solution like in 3 lines, but your solution is like 10 lines. If you can write these 10 lines in 5 minutes, it's fine. So it's not a problem. You don't try to oversimplify things. So if your solution is simple enough so you can implement it, just stop there. Oh, good. Oh, so let's see what we got here. So we have, yes, I see that we have this. So this C is basically my stack. So what we're doing here, you see again, you do this first. So when you see opening bracket, you push it into stack. When you see closing bracket, you remove it from the stack here and put this pair. So this array G will contain pairs of opening and closing brackets. Yes, that's all. So this is the whole code which kind of mark all these pairs. Now we just remove some pairs. So now I check how many pairs I need to remove. Not remove. Okay. So I need to add to result k over 2 pairs. So I take some k over 2 pairs, any of them, and okay, push them and sort them. Makes sense. So I just take all the positions that I need, sort them. Yeah, why not? And just print the symbols from this position. Yeah, nice solution actually. Nice solution. Problem D is again called regular bracket sequence. So again, all problems today are about regular bracket sequences. That's the problem I was talking about. So in this problem, I have some bracket sequence which is not regular, and I need to remove some character from this, to remove some brackets from this bracket sequence to have a regular bracket sequence. So I have initial bracket sequence which may be not regular. Then I need to remove some. Yes, I need to remove some characters from it to obtain a regular bracket sequence. Basically, what you need to do is again to build the subsequence. Yeah. So you have some sequence. You need to build a maximal possible subsequence of brackets, which is regular. Again, there are multiple ways to solve this problem. You can try to do it like we did before. So you can try to, again, when you build a sequence, you want to build the pairs of opening and closing brackets. So what you can do again, even if your initial subsequence is not regular, you can still try to, let's try something irregular. Let's say some tom, and something, and something like this. Okay, good enough. So even if your initial sequence is irregular, you can try to apply the same algorithm and find to build some pairs. So again, I will go from left to right and try to build as many pairs as I can. So I start from here. No, it's closing bracket. So when you see closing brackets and you don't have any opening brackets, then you just drop this bracket. It's not important because I cannot pair it with anything. Then you see open brackets. You add it to your stack. Add this to your stack. Then you see this pair with here. So this pair with here. Then again, you see closing brackets which you can't pair with anything. So you drop this. Then you put this to the stack. Put this to the stack. So now you have some pairs and you have some non-paired opening brackets in the stack. I claim that this opening brackets cannot be paired with anything because they always do that. So if I have any closed brackets, I will pair it. But if I have them in the end in my stack, it means I can't pair with anything. So you just keep them. So that's all. So you just go from left to right and just greasily make pairs. So every time you see closing brackets, you pair it with some opening bracket. In the end, you have some pairs. And this is the maximal possible number of pairs you can get. Good. Do you have any questions? I think the fun part is actually this problem is almost the same as the previous one. So if you look, let's check if Alex has the same solution for this problem or not, because solution is, oh no, it's more complicated. Okay. Because we don't need to output this sequence. We only output the length of this sequence. Yeah, but basically we do the same. So when we have closing bracket, we check if the balance is 0, balance is greater than 0. It means we have some. So this balance is basically the number of closing or opening brackets we have. Yeah. So if we have more than 0 open brackets, we just close one of them and have another pair. So this count number of pairs. And then we just output twice the number of things. The interesting thing is that we actually could use, I believe we could use this solution. Just copy this solution. We just, no, okay, you need to optimize something. So when here you need to check if the stack is not empty. And in the end, you just all output this, and it will be the bracket sequence you have. What we have in problem E? We have actually some graph problem, but it involves some bracket sequences. So we have bracket sequence, then we build some graph, and then we connect components in this graph. The way we do it, let me just show you why we have this picture. So we have this explanation for the second test case, for this test case, but let me show you why we have this. So I have this something like open, close, open, open, close, close. Yeah. And I have an edge if the sequence between these two indices is regular. So I have, okay, I named it from 1, 5, 6. So let's see which segments are actually correct bracket sequences. Do I have it? Is it correct bracket sequence? Yes, balance. It's called balance bracket sequence in this problem. It doesn't matter. So when you have balance bracket sequence, so I have bracket sequence on these segments, this segment, and this segment. Yeah. So that's why I have edges from 1 to 2, from 3 to 6, and from 4 to 5. Yeah. That's what you normally do. So if you have two pair in bracket sequence, if you take everything between them, you have a correct bracket sequence. And also I have this edge from 1 to 6. Why I have this edge? Because if I have this whole sequence, like from here to here, I also have a correct bracket sequence. So I also connect 1 to 6 like this. So that's how you get this picture, basically. What you need to do is to calculate a number of connected components in this graph. Here I have 2 connected components. Let's see. No, again, there are multiple ways to solve this problem. Let's check. First of all, let's build all the. So easiest way, I believe, is to draw the graph and then find the connected components. The tricky part is to draw a correct graph. So what edges do we actually need in this characteristic? Let's see. So you have some. First of all, why it's not good to draw all possible edges? So if you try to draw all possible edges, there may be like n square possible edges. Like if you have bracket sequence like this, yeah, then like any pair of like this correct has. So if you take any segment here in the middle, it will be a correct bracket sequence. So you have like n square possible correct bracket sequences. So you have n square edges, it's not what you want, yeah? So I wanna limit number of edges that I will build. Now let's see how you do it. No, let's think. No, what is the easiest way to do it? Let me think. There are multiple ways to do it. So let's for example, we can think about like this. Imagine you have this bracket sequence. Again, let's think about the bracket sequence as this line. When you have open bracket sequence, you go up. When you have closing sequence, you go down. So you have to go up, down, up. Let's say something like this. Up. Let's go down, up, down. What is this level? Let's say down. So imagine you have a bracket sequence like this. So what does it mean you have segment is a bracket sequence? It means the segments start at some. So it's like let's take some segment from here. Let's say down, here to here. Well, so this segment has a correct bracket sequence. How we check this? We check this because these ends are on the same level, yeah, and everything in the middle goes above this level. Yeah. So we need to connect points if they belong to the same level, and everything in between goes above this level. You can think about it like this. And then you need to, when you kind of split all the point by the level, then for each level find this point. It's one of the ways to think about it. Another way to think about it is, let me think. So, imagine how the bracket sequence look like. There are two cases. Let's look at the first. So first bracket is always an opening bracket. So if you have bracket sequence, the first bracket is always opening bracket. Let's look at the parent bracket. If the parent bracket is the last bracket, like this. So if the first bracket pairs with the last bracket, then we just have two pairing brackets. We can split all the brackets into pairs and just count all these pairs. So let's have two cases. So first case, I have a segment between two pairing brackets. Second case, when I have between not pairing brackets, so I have some segment. The segment, so this I'm talking about segments. Let me draw another picture just to. So you have your bracket sequence, and I'm interested about segments in the middle, which are regular bracket sequences. Yeah. So first it should start with opening bracket and finish with closed brackets. Yeah. So this should be open brackets. This should be closed brackets. Yeah. What happens in the middle? Doesn't matter actually. There are two cases. If I either have two pairing brackets, so if these two brackets are paired with each other, I can just find all these pairs. Yeah, like we did before. So we find all these pairs and build all these edges. So again, my final thought will be to build all these edges. So I find all these edges. Second case is when I have open bracket here, closed bracket here, but they do not match. So this open bracket match with some another bracket here. And this closed bracket match with some another bracket here. Good. So what do we do in this case? So we kind of want. So let's see. I want all these. Imagine you have a sequence of like this. Sorry, my explanation is not very explaining maybe, but I hope after some pictures you will understand what I'm talking about. So imagine you have multiple blocks on the same level. Yeah? The problem is I can pick any segment of these blocks like this or like this. So every segment of these blocks for my correct bracket sequence. Yeah. But if again, so what I want to, so in terms of my graph, what I want to do, I want to take every open bracket here and connect it with any closed bracket. So I want to connect this to this, to this, to this, and also to this. And I want to connect this bracket to this, and this, and this. I want to connect this bracket to this, and this, and all. Yeah. So I want to build all this, and problem is the number of edges will be up to n squared. But actually, what happens here? I just want to put all these brackets, all these shown brackets, all these open and closed brackets. I want to put all of them in the same connect component. Yeah. So all these brackets actually should belong to the same connect component. And the way I can do it is just by, again, so instead of doing all these edges, like and square edges, I can just connect them like this. I can connect this, like these brackets and these brackets and these brackets and these brackets. Like this. So when I see two blocks on the same level, I just connect them with the edge. And if you do it this way, you will have like a linear number of edges in the resulting graph. So again, the idea is to decrease number of edges in the resulting graph. Yeah, because the n is large here, I cannot make a graph of n square edges. So the way you do it usually, again, sorry, it's a little bit, okay, it's a hard problem. So the way you do it, so when you talk, we care about connect components in this graph, yeah? So we only care about connect components. So we only care about connectivity in this graph, yeah? So the way you solve problems like this is usually you just try to reduce number of edges in your graph with maintaining the same connectivity structure. So I want my graph stay connected, so everything which was connected stay connected, but the number of edges is reduced. And the way you do it is usually by replacing structures like this. So you have some strange structure which is very connected. So you have a lot of edges here. So instead of doing this, you're doing something simple like tree or some just sequence like this. Yeah. So here, instead of having a lot of edges connecting all my nodes, I will replace them. So instead of having all these edges connect my nodes, I will replace them with just this chain. Yeah. And I have about n square edges here and like n edges here. That's how usually you solve these problems. So you go from your dense graph to very sparse graph. Good. Okay, hope it was clear enough. Hard problem actually. Yeah. So let's see how you solve this problem. So again, how would I think about this problem if I need to solve it in a contest? I need to care about connect components in some strange graph. Yeah. So I just investigate how this connect components looks like. So which vertices I actually connected. See this structure and try to represent this structure with some simple object which maintains the same connectivity. Usually do it like this. So you go from structure like this, which has quadratic size, to structure like this, which has linear size. Let's check my solution. What? It's actually much easier. So if you have open brackets and then another brackets, then you have a new connect component. Okay, this is too smart solution for me. I'm not that smart person. Okay, so okay, So, okay, why does it work? Again, if you look at this picture and see what is connected, what is not connected. Actually, what will be connected? Okay, so everything on the same level will be connected. So we'll connect these two. We'll connect these two. We'll connect these two. We'll connect these. We'll connect these two. Everything on the same level. Sorry. Do you want to say something or not? If not, please mute your microphone. No? Okay. Okay. And here I also need to back up. Okay, that's genius. So every time I have a new component is when I create a new hill in this picture. It happens when I have some open brackets inside another open bracket, and then I start a new connect component, because everything on the same level here will be merged into a single connect component. Okay, it's too genius. Did you all solve it like this? Am I the stupidest person in this group? Oh no, that's what I'm talking about. That's how I will solve this problem. Yeah. Yes, find some digits. Oh, that's normal solution. That's how I was doing. Yes. Okay. So if you're confident enough that you can implement this, just implement this. Okay. So that's basically what I was suggesting to do. I believe maybe even harder. That's normal distance is to calculate the connect components. Yeah, here calculate balances. You have a temp. Why? This why you do put it in this? Okay. With balance I plus 1. If balance is so you joined to the previous bracket on the same level. Okay. Okay, so you just build this graph, make sure it is linear size, and calculate count this the connect components. Yes, that's how I would implement this problem if I would solve it. Okay. Okay, now some genius people implement it like this. They actually understand what's going on in this problem. Okay. Okay, cool. So again, it also happens in problems. Then you have multiple options. You can either find some nice trick and find easy solution, or you can kind of do a lot of additional work and build some solution which also works, but it's just much more complicated. Actually, both ways are fine. So if you find this easy solution, good for you. If you didn't find it, but find the hard solution, implement it, get accepted, good for you. So find the way which is suitable for you. There's no bad way to solve the problem. If you get accepted solution, then you solve the problem. Okay, nobody cares how your solution works. If it passes all the tests, you're fine. Now I'm interested in which is more popular. Okay, that also involves some different. Okay, this you also have some union find. Okay. I'm interested about statistics, which solution is more popular. Okay, another smart solution. Good, so some of you are really smart. I'm really impressed. Good, we have 3 problems left, let's go. So in problem F, we have some sequences again. And we need to build a regular sequence out of them, so we can pair some 2 of them, concatenate some pairs of these bracket sequences to form a regular bracket sequence. So we need to find number of ways to choose some 2 bracket sequences and two strings. They're not regular brackets, just 2 strings of brackets, and concatenate them and get a regular bracket sequence. Good. And again, how do you think about this problem? Again, I believe that the most useful representation of bracket sequence is like this. So you may not draw this, but again, at least keep it in your head that bracket sequence is something like this. So this is how bracket sequence look like. Yeah. So it's just profile like this, which doesn't go below 0. So this is 0, so it doesn't go below 0. So what happens if you split this profile? So I need to be able to construct this sequence like this out of 2 strings. So I need to split it into 2 parts. Let's say part 1 and some part 2. So what can I say about these parts? No, let's see. So what I can say about the left part? No, left part is the sequence which starts from here, never goes below 0. So if you calculate balance from left to right, the balance is always non-negative. So balance is 0, 1, 2, 1, 2. Yeah. So this is the left part. Left part must be the sequence such that if you go from left to right, calculate the balance, it never goes below 0. Yeah. So this is good left part. About the right part. Right part is actually the same. So again, problem is symmetrical. So the bracket sequences are kind of symmetrical thing. So if you do the same thing for the right part, go from right to left, you also have kind of it's suffix of bracket sequence, but if you reverse it, it will be prefix of bracket sequence. So it's kind of the same thing. So again, if you go from right to left, calculate balances, 0, 1, 2, 3, 2. Yeah. So to check if you have, so there are sequences that can be the left part, there are sequences that can be the right part. Yeah. And for the left part, it should be non-negative when we calculate balance from left to right. For the right part, it should be non-negative when we calculate balance from right to left. That's all. And now we just need to merge them. No, it's easy to see that we can merge them if they have the same balance in the end. So I need to, how you solve problems, again, like this. You draw this picture, like this. You may not specifically draw this picture, but something like this, yes? Or you can just draw the same with pictures. I can draw the same with just brackets. So you have this bracket sequence. You split it somewhere. You look at left part, look at the right part. What can you say about left part? Look, what can you say about the right part? Again, you see that in the left part you have this, it is prefix of some regular bracket sequence. So if you look at these balances, they should not go below 0. So they should all be non-negative. And this is the suffix of bracket sequence. Suffixes and prefixes are actually the same in bracket sequence. Bracket sequence is kind of symmetrical thing. So when you look about suffixes of bracket sequence, you do the same thing just from right to left. Yeah. So you go from right to left, calculate 0, 1, 2, 3, 2. Yeah. And now you finally check that you can combine these 2 strings into one. And you can combine them if they have the same balance in the end. And that's basically it. So you have these bracket sequences, you can combine them if they have the same balance. So you take all your bracket sequences, combine them by the same balance. Now, if you look at all opening bracket sequences with balance 2 and all closing bracket sequences with balance 2, you can combine any pair of them. So you just multiply number of these sequences by number of these sequences. And then you have all possible combinations of them. Oh. And so let's see how you do it. Okay, so let me copy this. Let's go to let's check it here simplicity. So let's read your solution actually. What would we do here? I'm too lazy today. I don't write my own solutions. I will just read your solutions instead. So we get with balances. So here we calculate balances. Why we have pairs? I'm not sure. We will check. Which is minimal balance and total balance. Why not? Yeah. Another thing is if you look at bracket sequences, they kinda can be explained by 2 numbers. So we didn't talk about this. Let's talk about it now. So any bracket sequence so if you look at any bracket sequence, the most important thing of this bracket sequence, so bracket sequence, again, basically a line. So you start from here and you just go from here. And everything so if you want to make a regular bracket sequence out of this line, actually the only thing you care about is this lowest point and this difference. So you care about this. So if you start with balance 0, you care about this lowest balance and this final balance. Everything else kind of not important for this sequence. So if this string is part of some regular sequence, it actually doesn't matter what happened in between. So if you put this string in the middle of some bracket sequence, so in order to the final bracket sequence to be regular, you just need to be sure that at this lowest point I don't go below 0. So if I have something here, so this initial level is at least equal to this. Yeah. So when I go to this lowest point, I don't go below 0. And you care about final balance because it kind of tells you how the balance change from here to here. Yeah. So again, any string of brackets can be explained by these two numbers: minimal balance and final balance. Yeah. So that's what we do in this solution. For every string we have in the input, we calculate minimal balance, calculate total balance, and just put these pairs in this array. It kind of makes sense to start with this. Yeah. So again, if your problem is about combining strings into some regular bracket sequence, then usually what you care about is only, not usually, always basically, is the minimal bracket and minimal balance and total balance of every bracket sequence. So this is pretty standard part. Yeah. If it cannot be greater than 0. It's always at least because you start with 0. It cannot be greater than 0. So if minimal balance is 0, it means I have good prefix. So this checks if I have a good prefix, if I have bracket sequence which doesn't go below 0, then I just put this brackets to them. Yeah. So these are good prefixes. If I don't have any good prefixes, return 0. Why not? Sort all good prefixes. No, why not? Why not? You need to group them by the balance. So I put these balances in this good, yeah. You put this total balance in the good, then sort them. You actually don't need to sort them. You just need to, no, yes, that's what you need. You need to count how many you have. Okay, you can do it like this. Okay, you can do it like this. Okay, here you group them by the same value. You have array, you sort it, and then group elements by the same value. You can, that's actually, that's a good way. You do it like this. It's actually a fast way. If you don't want the fastest algorithm, you can actually just make a map of counters. Just map from int to int, which will count how many elements you have, and just go from left to right and calculate. Yeah. I won't say just it's kind of overcomplication. You can do this part easier, but that's working. That's good. What? You do this instead of map. Why you don't use map? I don't understand. You can do the same thing with maps. You know. Here you basically implement map using sorted array. Possible, totally possible, just overcomplicated. Yeah, and here what you're doing in this solution? You sort, you put left parts in this data structure and then iterate over possible right part. So here I check if my string is a good right part. For every right part, I find all possible left parts with the same balance. Yeah. So here I check if it is a good right part. So total balance is equal to minimal balance. It means all the intermediate balances are above my total balance. Yeah. And yes, if it is good, then I find number of strings with the same balance. Okay, a little bit of, I think this part is overcomplicated, but yes, overall, nice solution. Good for you. Good for you. Problem G, again, it involves bracket sequences, but in different ways. So we have bracket sequence as, again, an object which we need to modify. So in this bracket sequence, we modify it by removing the pairs of brackets. So we have, initially we have some regular bracket sequence, and every time we make operation, we remove the pair of paired bracket sequences. Yeah. Sequence, yeah. So we remove every time we have a cursor staying in some position, and when we press button D, we remove both this bracket and the paired brackets, and continue. And we also move through this bracket sequence left and right. Yeah. And when we remove it, we move to some strange position. Like if we can, we go to the right. Yeah, so we move to the next bracket to the right. If it was the last bracket, we move to the left. So this is just some strange explanation of what we do. It doesn't matter. That's all. What's important in this problem? So we need to have some data structure which allows us to move left, right, and also remove objects. There are multiple ways to do it. So depends on what you like. So if you like, for example, so what we need? We have some structure of elements. So we have some elements, basically, yeah? And we have some current element. We need to be able to move left, right, and to be able to remove some elements. So we need to remove elements and move left, right. That's basically what we need in this problem, yeah? So there are multiple, well, so from the easiest way, probably, again, theoretically, at least, it will be just using the linked list. Linked list is not very useful in structure, so it's not that popular nowadays, because usually you have more easy data structures. But still, it's actually very easy, and it is both easy to implement and easy to use, and it's fast also. So how linked list works? So you just make, for each element, you maintain the link to the next element and to the previous element. Yeah. How to remove the element? So when you want to remove the element, you need to just change the links. We change link from here to here and from here to here. Very easy. That's all. And so you maintain link to the next element, to the previous element. So it's easy to move left and right. And it's easy to remove element. When you remove element, you just find the next element, find the previous element, and make these links in both ways. Little bit, it may be a little bit tricky when you remove the last element, like the leftmost element and rightmost element. So when you remove element this, there is no left element to the left, no previous element. So it's kind of maybe tricky to remove it. The way you solve it is just to add another additional element here and additional element here, like to this barrier elements. And yeah, so add these two virtual elements in both border of your linked list. And now again, it's quite easy to do. So this element just say I am the border of this linked list. Do not go. I forgot the word. Do not go over me. So I am here as the border of the element of the linked list. Do not go behind it. Okay. So again, linked list is not very popular in competitive programming because there are usually much easier alternatives. But for example, in this problem, it may be the easiest data structure to use. So if you never used linked list, just try. It's not that hard. You just maintain two pointers. For each element, you pointer to the next element, pointer to the previous element. Pointer is usually easy to implement just by index. Yeah. So you maintain two arrays of indexes. You play like next of I. For each element, you maintain. You remember the number of next element. Yeah. Just number of next. So this is I. This is next of I. And the previous. Yeah, so to the left. So you maintain index of the previous element, index of the next element. So when you remove element, you just find the previous, find the next, move these links, and so on. That's basically it. So first of all, you need to analyze this bracket sequence, find all the paired brackets. After that, you just do this, and that's all. You just need to move left, right, and remove these elements. When you remove element, you just move these links. Another way to solve it probably, let me show. Sometimes you have special like this, which is more general data structure. You have some elements in a row again. You have some array of elements. Sometimes you remove some of them. So some of them are removed. And you sometimes pick the next element. So you pick the position, and you need to find the closest element which is not removed. So you start from here and find the first element which is not removed in both directions, like here. So from this position, I have the closest element to the, let's go to the right. So you need to find the closest element to the right which is not removed. Okay, and you can do it using DSU or union find. So, but basically you do it like a normal DSU. You first have elements pointing to themselves, like a normal DSU, like the root is points to itself. When you remove element, you point this to the right. Point this to the right. And then, like a normal DSU, you apply the path compression. So when you ask for the closed element here, like you do in DSU, you follow this path, follow it to here, and then compress it, so you move this point to here. Again, it's like normal path compression in DSU. Okay, if you don't know how DSU works, just watch the lecture. Okay, so you can do it the same as you do in DSU. Just make the pointer to the closest element to the right, and then when you ask for the closest element to the right, you follow this path, and then apply the path compression, like in DSU. Exactly. It's actually like you can do it specifically like DSU. You can just think about it like all the blocks of elements of like this. They form sets in DSU. Yeah. So every element like this, and when you remove the element, you kind of merge these two sets into one. So it's actually DSU. Okay, so you can apply simple DSU, but it will be not linear. So if you use linked list, you have linear algorithm. Here it will be not exactly linear. It will multiply by some inverse Ackermann function, but it's almost linear again. DSU are almost linear. It's actually interesting. This problem was not that popular, so you don't need any specific knowledge on this problem. Some simple data structures, actually like linked list, simple data structure, and just a lot of realization. Not a lot of, just it is some implementation heavy problem, I would say, comparing to previous ones. We can do it like this, so it's small. So what? Sorry. 500. How we do it? It's interesting why this part is fast. Okay, I don't understand how it can fit in the time limit. So you simply erase. So you simply erase the part in the middle, like just take this vector and erase the part. How can it possibly be fast? Because C++ is really fast. Interesting. So C++ can do it in less than 2 seconds. You never underestimate the speed of C++ nowadays. Okay. So it's really you can do this number of iterations in this point. Nice. I would never expect it to work. So more than C++ is that fast. Good for you. So if you find that this solution should work and you try so if it just works by accident, also fine. Sometimes it works like this. So you don't expect your solution to work and just run it and it passes all the tests. Good for you. Again, nobody cares how your solution works. If it passes all the tests, it's fine. Good. Okay, here's another solution. Okay, that's more like it. Node. Okay. Here you have a linked list actually. So LP is pointer to the previous element, RP is pointer to the next element. Overcomplicated, I would say. So pose go to minus. Okay. I believe you don't change this pose never. So this pose is always equals to I believe. Yes. A little bit overcomplicated. You can just okay. You don't need this. But yes, overall, that's what I would expect. Yes. So here you you use a left pointer. Here you go to use a right pointer, and here you find the element and remove them. You remove one, remove second. Yes. Basically, remove one bracket, remove another bracket. Good. Final one. So final problem. So it actually involves some. Again, so it involves some algorithms and some actually intellectual force. So what we have in problem H, we have two sequences, and we need to build a third sequence. What we need to do? So first of all, we have another definition of bracket sequence. So if you're interested, here's another definition of bracket sequence, a little bit more formal than before. So it doesn't use any like strange things like we can add something to make a regular expression. Okay. This definition is a little bit different. So in this definition, we just use normal like recursive definition of something. This more like mathematical way to explain what is a regular bracket sequence. So we say that just this thing is bracket sequence, or sometimes you say that empty sequence is a regular bracket sequence, and we say that we can add brackets on left, right, and we can concatenate two of them. So by applying these operations, this and this, we can build any bracket sequence. Again, this is more formal way to define bracket sequence. It's not that useful for you probably. No, it's not very visual. But it's like formally defines what is a bracket sequence. And yeah, here's another definition of subsequence. If you forgot what is subsequence, here is definition. Now, what we need to build? We need to build the shortest regular sequence such that both the given sequence are subsequences of it. So we need to find a sequence, or find a regular bracket sequence, such that both given strings are subsequences. Good. Okay. So how would you normally solve this problem? So again, if you're new to some dynamic programming and stuff, so how you normally solve problem like this? So you have, imagine you have two strings. Like we have two strings, let's say ABA and something like BAAB. Yeah. Imagine you have two strings and you need to find shortest string such that both the strings are subsequences. So you produce something like what? I believe AB, something like this. Yeah. So this string can contain both these strings as subsequences. This ABB. So it's not substring, it's subsequence. Yeah. So ABB is like this, ABB, and BAB like BAAB. Yeah. So both strings are subsequences of this. So how you usually construct things like this? No, you usually construct this the same way, like you find there is more maybe popular problem of finding longest common subsequence, but here we need to find the shortest common supersequence. Yeah, so we need to find sequence which contains both our sequences. We do it in the same way. So again, imagine you have your sequence. How would you check if it contains both these elements as subsequences? No, you go from left to right and check. If you have the same element as here, you mark it out. So I have, imagine you want to find sequence ABB. You go from, let's say, A, and B, then skip, B. Yeah. So you go from left to right and find this character, then this character, then this character. So in the middle, what's happening? So if you stand here, for example, if you have character ABA and something here, yeah. So if you stop here, in the middle of your process, then in the first sequence, I find character A, then find character B, then I'm looking for character B. Yeah? So I'm standing here now. I found already A, found B, looking for B. Here, I found B, found A, I'm waiting for this A. Yeah. So again, what's happening in your dynamic? So if you try to solve this problem using dynamic programming, what do you need to have? So you have you already constructed some prefix of your result. Yeah. What you have? You have you already have some prefix of the first string and some prefix of the second string. So let's build a dynamic program like this. Let's say dp of I and j will be shortest string that contains both string A. Let's call them A and B. Capital A, capital B. Let's call A from 0 to I and B from 0 to j. So I will fix some prefix of the first string, prefix of the second string, and try to find the shortest string which contains both this prefix and this prefix. Now, how I extend this dynamic program? So what is the next character? So if the next character is B, then I can extend this suffix, the prefix. Yeah. If the next character is if this character is A, I can extend this prefix. Yeah. If it happens I have the same character here and here, I can take this same character and extend both these prefixes. Yeah. So you kind of move from dp ij to either dp ij plus 1 if you extend sec prefix, or you move to dp I plus 1j if you extend the first prefix, or you extend the both suffixes if you have the same letter. Again, if you're not very good in dynamic programming, just go and learn dynamic programming. Yeah, just go learn dynamic programming, solve a lot of problems about dynamic programming. This problem is quite standard problem in dynamic programming. So building the building the string which contains to your string as a subsequences is actually quite standard problem of dynamic programming. Okay, maybe not the very standard, but quite standard. Now, what's in this problem is actually a little bit different. In this problem, I don't need just to build the shortest string which contains both my subsequences. I also need it to be a regular sequence. So I also have another constraint that this resulting string should be a regular bracket sequence. How I achieve this? No, I achieved again. Imagine you build this final sequence. Again, you build it from left to right, yes, and you what you interested in? You're interested how many characters of the first string you already seen of maximum length of this prefix. You care about maximal number of characters of the second string you see. Yeah? So you care about length of this prefix, and also you care about your balance because you want to be a regular bracket sequence. Yeah? So you just add to your dynamic program another parameter. So another parameter will be just your current balance of your bracket sequence. And you check if you add the opening bracket, you just increase balance. When you add closing bracket, you decrease this balance. Again, every time you have two options. You either add another opening bracket or you add the closing bracket. That's all. And now we have the dynamic program of these three parameters: length of first prefix, length of second prefix, and balance. That's all. And again, we have 200 here, so the time complexity will be like 200 cube. It's enough to pass the test. So 2 people solve this problem. Actually, good. It's a hard problem. So it's maybe one of the hard problems we have in this series by now. Yes, so that's good. Again, if you're not good in dynamic programming, just find the specific. I have some lectures about dynamic programming, and there are specific contests about dynamic programming. Just learn how to do dynamic programming. It's usually kind of standard. So there are a lot of problems that you kind of, after you solved all these problems, you understand what's going on. So maximal common subsequence is one of them. Here is slightly different, but it's quite similar to maximal common subsequence. No, yes, you see also. So okay, it's a little bit overcomplicated. I believe you can do it more simple way, but yes, what you do. So you check which bracket you add. If you add opening bracket, you just increase the what? White minus 1. Because that's previous. Okay. So if I add it, okay, you do it backwards. Okay. So you do backwards dynamic programming. Okay. So you look at your current state and look at the previous state. So if last bracket was opening bracket, it means the previous balance was u minus 1. U is your balance. And if it's 4, it will be plus 1. And then you look at both strings, check what was the last character. You have too many options here. You can simplify it actually, but okay. You basically need two options. You need to look which bracket you put, close bracket or opening brackets. Then depending on what characters you have in the strings, you have these indices. You have either I minus 1 or I plus 1, or both. You do it like this. Okay, so so in the end you add all the remaining closing brackets, because if your balance is not 0, you need to also add some closing brackets in the end. Makes sense. What's this? We also need to output the result. Okay, so here we find the optimal length, but we also need to, okay, we need to output the bracket sequence itself. So we need to build. Okay. So we need to, again, like you normally do in dynamic programming. You remember the previous state of your dynamic programming, and then go backwards and build your object. Okay, not very pleasant problem, I would say, but I'm actually very proud that 2 of you solved this problem. So and you feel okay, you barely fit it into 3 hours. So 3 hours actually good timing for problem. So if you think you may solve this problem but you just didn't have enough time, try to solve it. This is a nice problem to solve. So if you have all these ideas but just didn't manage to solve it, just try to solve it. It's a good problem to solve. Okay, all for today. See you next week.